Math is the best. Math is life. Mr. Ang, the best teacher in the West.
Alright, let's go over this practice test. I gave this out on April 18th, 2022. In this one, I have an equation sign, so I'm just going to move everything to the left side. I'm going to reorder it as I write it. You realize the highest degree tells you the total number of zeros. And here I have real or imaginaries. Remember, imaginary zeros have to come in pairs. So if you had, for example, 0 imaginaries, then you would have to have 3 reals. If you had 2 imaginaries, then you would have to have 1 real. So in each of those scenarios, the only one that works is where you have 1 real, which would be choice B. For question number 3, use a graphing calculator to solve. I'm going to move everything to the left side. So I have x to the third minus 4x squared plus 7 minus x minus 2 equals 0. And then notice those are like terms. Move the negative x in front there, plus 5. Now you'll notice that it says a graphing calculator, so I'm going to use Desmos. You can also use Graphing Calc. Let's go ahead and put this in here. Remember my trick. X is x to the third minus 4x squared minus x. Remember not to use the plus signs or the multiplication signs on the right side. The left side is the variable. Minus x plus 5. If you tap it 2 times, you'll get solutions there. All right, so we're looking at our choices here. That would be choice A. All right, question number 4 gives us this weird looking graph, and it tells us f of x and g of x are shown. But I gave you guys a hint. Don't worry about f of x and g of x on the graph. Just set equal to 0. The equation to the right. So the same thing we've done before. I'm just going to move these over to the left side. So it'll be negative x, negative 2. I'm going to have those there in pink. So then I'm just writing this over here. X to the third minus 2x squared plus 4 is now equal to 0. And I can just combine like terms there. Plus 2. Okay, from here you can do a couple things. You can factor by grouping, because I have 4 terms. You can put this into the box, or you can just do the 2 GCFs method. So I'm just going to put it here in a box. Remember, that goes into my favorite letter, the Z. X to the third minus 2x squared minus x plus 2. Here we're just going to take out not the greatest common factor. This is just common factor, so this would be a x. This direction would be an x squared. This direction would be a negative 2. And this direction would be a negative 1. and then you can just multiply on the outside to get what you have on the inside. So then what's on the outside, I'm going to write now, is our factored form. And here, when it says find solutions, remember the solutions are the same thing as the x-intercepts, the roots, or the zeros. And each of those just basically mean x is equal to what? Where is it across the x-axis? This one you could factor again, or you can use the square root method. The fastest one I think is just the square root method. So now I'm just going to solve each of these. Add 2. You're going to have x equals a positive 2. Over here I'm going to add 1. X squared equals 1. To get rid of the power of 2, you have to take the square root. And remember, when you do this now, you have a plus or minus. Square root of 1 is just 1, and you're just left with x. So this is our answer. Again, why do you add the plus or minus? Is because if you have a number multiplied by itself equals 1, you could put in -1, or you can put in +1, and you'll still get that. So that is 2 solutions there. So let's go ahead and highlight each of those. So I have 2, which is x equals 2, which is D, and then +1 and -1, which would be B and C. Question number 5 says find the factors. I'm going to count the number of terms we have here. And we have 4 here. So you can just put it into the box with the Z method. I'm going to use the 2 GCFs method. Just basically means what's the greatest common factor here. That would be x squared, so that would be x minus 5. Same thing over here for this blue box. I have a +9, so that'd be x minus 5. You know this works when you have these two, so essentially what I'm doing is I'm going to factor in x minus 5. And then you're left with x squared plus 9. And you can put that in parentheses. So how does that work? Again, you could take the blue and multiply it to the orange and get what's above. And multiply the blue times this light blue to get what we have above. Okay, so a big idea is figuring out what are the factors. In factors, you're not solving. It doesn't say x equals. You usually have parentheses, or basically it doesn't have x equals. So the x squared plus sign, that'd be A, because it says select all that apply, and x minus 5. Question number 6, it says now to solve, so I'm going to get an answer that says this. So basically I'm going to have to try to factor or do something. I have 4 terms here. Let's try putting this into our box. Again, you want to put this into like a Z, and the Z kind of tells you how to write it. All right, let's go ahead and try to pull out the, be careful now, it's not just the greatest common factor, I'm going to do common factors. So go in this direction, it'll be x squared. This one I'm tempted to do x to the third, but it's going to be x squared. The reason why is x squared times x squared gives me x to the 4th, so I can't do x to the 3rd. Okay, going in this direction, I'm going to do an x, and this direction it will be a 4x. Let's see. that'll just be a 4. Because then when I multiply, 4 times x squared gives me 4x squared. So now I have x squared plus 4 and x squared plus x. Now this one looks weird because you can pull out a greatest common factor of x there, and then you would just be left with x plus 1. Now to solve these, I'm going to set each of these equal to 0. This one I'm going to subtract 4. I'm going to take the square root. Remember, when you take the square root of an equation, you have to have plus or minus. So my answer is going to be x equals the square root of -4 is -1 times the square root of 4. And that is the square root of -1 is I, and the square root of 4 is 2. Okay, this one here, x equals 0, this is a common mistake. People don't get this. So if you did take out an x in the beginning, it would have looked like this. Just reduces all of the powers by 1. And you would have found out, again, you always want to set the GCF equal to 0. Common mistake. And then you'll get x equals -1 here. These choices would be choice D. All right, to get this into quadratic form, we're going to look at just the first 2 terms that are highlighted in this blue box. And really, what I'm doing here is taking that first term, and I want to solve this. What can I put in there so that it will equal 36x to the 4th? And if you want to, there's you can guess and check, or you can put like a u in there because that's the letter they use. And to get rid of the power of 2, you just take the square root. So you would get 6x squared is equal to your u. 6x squared is equal to your u. So, and then the original problem will look like this. Let's put this in a different color. Okay, so now let's put that. So then I have parentheses 6x squared. Well, I'm going to have to square that, because 6 squared is 36, and x squared is x to the 4th. I'm going to do the same thing over here, 6x squared. Well, to make that true to the one above it, I would have to put a 2 here. Okay, so basically our u value is going to be 6x squared, and that would be choice C. Question number 8, find the solutions. It's the same thing as when you solve for x to the 4th plus 5x squared minus 36. So you can use the method above to do the substitution to make it quadratic-like. So if you were doing the substitution method, it would just look something like this. I want to solve for that u, so that would be x squared is equal to the u. So you would do something like this. X squared and x squared. And to make that true, to be like this, you would have to do the power of 2 plus 5 minus 36. And then when you do the substitution, you're going to do your u, So it would be u squared plus 5u minus 36, and you just factor that as a quadratic like. You can also just use the x method. Remember, when your a value is 1, like we have here, then you only need your x. So a times c is negative 36. So this is now a different way. B value is 5. The two numbers that I need, there it is, 9 and 4. Okay. Now, if you're not sure, I'm going to show you guys the box. I didn't want to jump a step. I could have, but remember, the a term always goes in the top. The c value always goes in the bottom, right? And here, this is splitting this term. So notice it has an x squared. So it'll be 9x squared and negative 4x squared. Okay, so then just taking out a common factor. This one looks to be like a negative 4 and a positive 9, and that works. So pay attention, this is the factored form. This is not solved. To solve it, I'm going to set equal to 0. Set equal to 0. Now you could factor again. It's not wrong. Could probably make your life easier if you wanted to. But I can just use the square root method to solve here. Over here, I'm going to add 4 to both sides. And then take the square root. Pay attention, x equal to positive or negative 2. Then over here, x squared equals negative 9. Take the square root. Remember, that's the square root of negative 1 times square root of 9. So remember, you have plus or minus. Negative square root of negative 1 is I, and square root of 9 is 3. So our two solutions, positive 2 and negative 2, and positive negative 3i. Question number 9 says, what are the factors of x to the third plus 25? Well, I want you to notice that you have two terms, and I'm not going to put a 0x here, and I'll show you why. And what I'm trying to show you is not using your x in your box to factor. This one has a 3, and half of 3 is 1.5, not 1. So if it is half, then you can go ahead and do that. But because we can't do that, we cannot factor it. So what is this? Well, it is a power of 3. A power of 3. So this is called a sum of cubes. And really, x to the third plus 125 is if we can put it into this. The cube root of 125 is going to be 5. Why did I write 3 there? You can put that in your calculator. So this one will be x, and this one will be 5. So this is our a, this is our b. And then we have the SOAP formula. A plus b, a squared minus ab plus b squared. Where's SOAP? Same. Opposite, so the opposite of plus is a minus, and AP means always positive. I'm going to substitute in our values here. So A is x. Let's change our B value to, oops. Just going to change it to a different color. Change it to orange. So So every b value is now going to be 5. And I'll just come back in the white color. So I have x plus 5, x minus 5x plus 25. This is our answer. And I want to note that this is never factorable, not factorable, or another word of saying that is prime. And that would be choice x plus 5. That would be this one. A.
Hello, so I will be reviewing number 13 of the Module 3 test. Now here it states, use synthetic substitution to find f of -2 if f of x equals x to the third power minus 3x to the second power plus 5x minus 7. Let's go ahead and highlight what we're looking at. We have f of -2 and f of x in this equation. And now we're just going to go ahead and write it down just to see what we're looking at. So what we're going to be writing down, since we already have f of -2, is we're going to write -2 here. Okay, and then we're going to write this L-shaped box, not completed box. And then we're going to go ahead and write the equation down in there to start off our synthetic substitution. So we see we have x to the third power, and that is going to be 1. We have -3x to the second power, which is just simply going to be -3. We have positive 5x, 5, and -7, which of course is going to be -7. Now the first step into this is actually bringing down the first number. And throughout this synthetic substitution, you're going to be seeing a pattern of multiplying and adding. And so I'm going to be demonstrating this. So as I mentioned, let's bring down the 1. Always bring down the first number, which here it is 1. And now we're going to start our multiplying and adding pattern. So -2 times 1 equals, that is, my pen, -2. And now, once again, we're going to add. Here, we're going to start off by adding. And so we're going to add -3 and -2. And that is -5. And now we're going to multiply -2 and -5. What does that equal? That is 10. Once again, we're going to add 5 plus 10 equals 15. Now, -2 times, 15 equals, that is -30. Now with these two numbers, we're going to add -7 and -30. We're going to add them, and what do we get? -37. We can also view this as our remainder, but it is also our answer for f of -2. So f of -2 equals, go ahead and just circle this, -37. And let's always box our answer. Let's go ahead and just write this down here. And this is simply just our answer. F of -2 equals -37. Thank you.
All right, question number 14. If x minus 1 is a factor, I just want to point this out. That basically means that a couple of things. It could be f of 1 equals 0. That's an order pair 1 comma 0, which is the same thing as x equals 1. They all work. So now let's just say you ignored the orange and you're trying to find the other factors. You could just put all of those in, and you can use synthetic division. You can use long division, or you can use the remainder theorem and just basically see if the remainder is 0, then it's a factor, right? You could do that. I think that's longer. You're doing multiple problems. But with that orange clue in the beginning, then I'm just going to take this as a factor and make it a 0. So add 1. So x equals 1. This is a 0. And I use a 0. I find synthetic substitution or division easier or faster. Then I'm just looking at the coefficients. 1, -6, 11, -6. 1, -6, 11, and -6. I already know it's going to equal 0, but what I want is the end product here. Bring it down. Multiply 1 times 1 is 1. Add down. 1 times -5, that'd be -5. Add down. Multiply, add down. So I already knew that, right? But what I wanted is this. This will become x. I already know this. X minus 1. 1x squared minus 5x plus 6. And you don't include the remainder. Now, this I can factor again. Remember, I only have to use the x because a value is 1. So a times c is 6. B value is -5. Two numbers that multiply to 6. 1 and 6, 2 and 3. And they're both going to be negative. So now I have x minus 1, x minus 2, x minus 3. Okay, so use a different color. X minus 3 is here, that's a factor. X minus 2, that's here, that's a factor. X minus 1, that's not x minus 1, that's x plus 1, so not a factor. And I don't have x plus 2, not a factor.
Hello, so I will be reviewing number 15 of Module Test 3. So let's first and foremost go ahead and read the question. Use synthetic substitution to evaluate f of 3 when f of x equals x to the third power minus x to the second power plus 3x minus 4. Fill in the blanks to complete the algorithm. See, first and foremost, we can see that they already give us a table, which is perfect. Let's go ahead and highlight what they give us, which is f of 3 and the f of x equation. Now, first and foremost, our first step into this is always bringing down the first number there. Here, our first number is 1. Go ahead, let me make this a little bit thicker. And that is going to be 1. Now, we're going to see a reoccurring pattern of multiplying and adding. Here, we're going to be multiplying 3 and 1. 3 times 1 equals 3. Now here, we're going to be adding. -1 plus 3 equals 2. Once again, we're going to multiply 3 times 2 equals 6. Now here, once again, 3 plus 6 equals 9. Once again, multiplying, 3 times 9 equals 27. Now here we have -4 and 27. What does that equal? 23. And in a lot of manners, we can say that 23 is our remainder, but it is also our answer for this question. So let's go ahead and write that down. F of 3 equals, what is this number? 23. And let's always box in our answers. So once again, our answer for number 15 is f of 3 equals 23. Thank you.
"17, what are the possible number of positive real zeros in this function?" So we kind of created this chart. And the positives, you're just going to count the number of sign changes. So this is plus, positive, positive, that's a no. Positive, negative, yes. Yes, and yes. Then you just count up the number of yeses. We have 3. So in my table, positives, negatives, imaginary, and total. With 3 yeses. Okay. So you have to count down to 0, and you have to count by 2. So that'd be 3 and 1. Okay, to do the negatives, the possible negative real zeros, we have to substitute in negative x for every x value. Negative x to the 5th power is just going to be negative x to the 5th times 2 is negative 2x to the 5th power. Negative x to the 4th power, remember when you're in doubt, write it out. And if you're still struggling with positive and negatives, I would just change the x's into negative 1s. And just put that in your calculator and it'll tell you if it's a negative or positive. You could have also put in that into your calculator. So positive 3x to the 4th, negative x squared, negative 2x minus 1. Okay, then I'm going to do the same thing. Count sign changes. Yes, yes, no, no. So then I prematurely had put, I have 2, so that'll be 2 comma 0. And what you're doing here is now putting all the combinations. 2, 0, 2, 0. The total number is, in this case, 5. So 3 plus 2 plus 0 equals 5. 3 plus 0 plus 2 equals 5. 1 plus 2 plus 2 equals 5. And 1 plus 0 plus 4 equals 5. So these are all of the combinations. Where the possible, what are the possible number of real zeros? Well, that's my green. And so I would circle D and B. D and B for number 17, and then you have your answers there at the bottom, B and D. All right, number 18, consider f of x equals x to the 4th minus 8x squared minus 9. It's asking me about real zeros, imaginary zeros, and repeated zeros. I'm just going to solve it. Solving is basically finding zeros. And I'm just going to do, this is 3 terms, 1, 2, 3. Half of 4 is 2, so I can use my Xbox method. This is my A, B, and C. So A times C is negative 9. My B value is negative 8. And my 2 numbers are going to be 9 and 1, and that'll be negative. So the faster way is, well, if you realize that you're going to be doing x squared. Now, if you don't understand that, you can just go back and do your box. Put in your terms, x to the 4th, first term, last term is the bottom right, always. And then remember, this is splitting your middle term, so that would be x squareds. And then I'm just gonna take out the common factors. Multiply by double checking from the outside to the inside, that works. So we already have this, x plus 1, x minus 9. Okay. If they had 3 terms there, I would factor again, but here I can just set equal to 0 and solve. Subtract 1, square root. Remember when you take the square root, you have plus or minus. Over here in orange, x squared equals 9, square root, x equals plus or minus 3. So you'll notice this one has imaginaries for I, so that'll be 2. There's 2 plus and minus 3. Remember, 2 plus 2 is equal to the 4th degree. The function has any repeated zeros. So a repeated 0, if you expand this out, or when you actually had factored it, say factor it, you would have gotten this. And in blue, that would have been x plus I, x minus I. Whoops. Whoops. Let's find a different color. So right here, you'll notice that none of those are exactly the same. Like you don't have x plus 3, because then you can say x plus 3 squared. The repeated 0 is kind of like where it bounces. It bounces off. That's what repeated 0 means. So we have 0 of those. All right, question number 19. Sketch the graph of a 3rd degree polynomial that has the factors x plus 2, x minus 1 squared. Okay, I already know it's 3rd degree, not because it tells me, because if you actually multiply this out, no, you could really multiply it out, but you don't have to. I'll tell you a shortcut. But to get your whole polynomial, it would be nice to have the whole thing. Okay, so I already know it's 3rd degree, x times x times x. In the polynomial, you have x to the 3rd. Now, I want to focus on this because we're looking for a basic, and the easiest 3 there is a odd degree. And the easiest one we know is x to the 1st, which looks like this. So my arrows are going to go like this. Now, the math operation there, the leading coefficient, can't spell, is positive. So the arrows stay. If it was negative, the arrows would go here in dark blue. They would flip. Okay? All right, well, what else we need here is when you solve these, and remember this is just written twice, so it's just twice. So if I put it at -2, okay, what does it mean to have, why would you put 2 dots here? 1, and then let's just say I put another dot over it. What happens there? Well, this is called the multiplicity of even. It's even because 2 is an even multiplicity. What does that mean? We kiss. Let's do a different color. This one. This one has a multiplicity that's 1. That's an odd multiplicity. And we do shoot throughs. Okay? One last thing I want to get from here is an easier way of getting the y-intercepts. So if I just multiply the constants, 2 times -1 is -2, -2 times -1 is +2. What I'm trying to say is you don't have to multiply all this out to get the whole polynomial. I know the last part is going to be a 2. this constant is our y-intercept. And that was the same in slope-intercept form, mx plus b. So my graph will go up to here. Okay, let's put it together now. You're gonna go from left to right. So you're gonna start on this left arrow. And then you're gonna end up here, okay? So we're gonna go shoot through. I have to go through that point. Doesn't mean you bounce there, but you do need to bounce off the orange and go through here. Okay, let's see this how close we got to in our graph. It's pretty good, right? Hopefully that was helpful. See you.
Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.